Today we're going to look at the three basic trig functions, sine, cosine, and tangent, which relate the sides of a right triangle to the acute angles in the triangle. We'll use the acronym SOH CAH TOA, to help us to write these. We're going to start out with the sine, so, and we'll first identify an angle that they will give it to you or ask you about, and we'll label the side lengths by the hypotenuse, the side opposite of the angle in question, and then the side adjacent to the angle in question. Remember, the hypotenuse never changes. It's always the side across from the right angle. The side opposite of your angle, you can draw a line across to it, and the adjacent side always connects to your angle. So if I need to find the sine of angle C, then I use the acronym SOH. That's the part that deals with sine, and it is opposite over hypotenuse. So the sine of C is my opposite side over my hypotenuse. And usually they'll give you numbers for these, and we'll set up that ratio, which is a fraction, and we will reduce it as necessary. In this case, they just give us side length, so we'll say the sine of C equals AB over BC. Next, let's look at another triangle, and let's find the cosine of that triangle using our SOH CAH TOA. CAH deals with the cosine, the CAH. So the cosine is adjacent over hypotenuse. That's what the A and the H stand for. So they'll give us an angle to look at. In this case, say angle A. I will circle my angle so I can identify my sides. My hypotenuse never changes. My opposite is always across from the angle, and adjacent connects or joins to the angle. So to find the cosine of angle A, I use CAH, adjacent over hypotenuse, and I've already identified those. So the cosine of angle A is 6 because it is adjacent, over 10 because it is the hypotenuse. And this fraction reduces to be 3/5. Make sure you reduce all fractions if they can be reduced, or you will not. Okay, next let's look at tangent, which is TOA in the SOH CAH TOA. And tangent is going to be opposite over adjacent, TOA, tangent opposite over adjacent. All right. So let me label the side lengths. We'll just make it a 3, 4, 5 right triangle, make it easy. And if I'm looking to find the tangent of angle B, I want to identify the angle and label my side lengths. So I circle my angle, label my hypotenuse, my opposite, and my adjacent. Remember, the adjacent connects to the angle. The hypotenuse is always across from the 90-degree angle. So the tangent of angle B is opposite over adjacent. So it is 3 over 4, and this fraction does not reduce. Okay, now let's look at another triangle, and let's find all three trig ratios from this triangle. So we'll use the whole SOH CAH TOA. We'll find our sine, our cosine, and tangent. So let's look at angle A, and let's identify our side length. The hypotenuse is always across from the 90-degree angle. It's 13. My opposite side across from the angle is 12. And my adjacent side is connected, and it is 5. So if I'm going to find my sine of A, my cosine of A, and my tangent of A, I use my acronym. Sine is opposite over hypotenuse, cosine is adjacent over hypotenuse, and tangent is opposite over adjacent. SOH CAH TOA. So the sine is opposite, which is 12 over 13, which is my hypotenuse, 12 over 13, opposite over hypotenuse, and it does not reduce. Cosine is my adjacent, which is 5, over my hypotenuse, which is 13, so it's 5 over 13. Tangent is opposite over adjacent, which is 12 over 5. And none of these ratios reduce. If they did reduce, we would need to reduce them down. You can use your calculator to help you do that. So I want you to take into consideration that there's another acute angle in this triangle, angle B. How would the sine, cosine, and tangent of angle B differ from the sine, cosine, and tangent of angle A? Let's ponder that.